Okay, welcome to Precalculus Concept 13F. We're going to graph a polynomial function by hand. There's 3 boxes. Before we can learn to graph a function by hand, though, we have to understand this thing called turning points. Okay? Turning points. So here it is. It's an if-then statement. And it says this: if f is any polynomial function of degree n, then f, meaning the function, the graph, has at most n minus 1 turning points, so one less than that. So as an example, if I have a 17th degree polynomial, then I can only have a maximum of 16 turning points. And a turning point is just basically turning around, like walking down the hallway and then turning around. That's a turning point, okay? So let me give you some examples with some pictures, because who doesn't love all of that stuff? Okay, so here's the polynomial, x to the third plus 2x squared plus 1. First, you should note that the degree is the highest value term, so the degree is of 3. So therefore, it can have at most 2 turning points. So let's take a look at the picture of the graph really quickly and understand what they mean by that. So this point right here, that's a turning point because it turns around. And that point right there is a turning point because it also turns around. So the graph was growing, and then it's shrinking, and then it grows again. So notice that there is a maximum of 2 of those. Okay? Let's take a look at this one. Let's do x to the 5th minus 6x to the 3rd plus 8x plus 1. The degree is a 5. Okay? The degree is worth 5, so therefore I can have exactly 5 minus 1, of course, which is 4 turning points. Okay? So let's move this over here and make it bigger, and let's take a look and see if this is confirmed. There's a turning point 1, there's a turning point 2, there's a turning point 3, and there's a turning point 4. Notice it doesn't say that it has to have this many. It can have up to this many. So hopefully that makes sense to you, okay? That's where we're going, and that's what turning points means. Okay, box number 2, we are going to do an example together. I'm going to show you how to graph a polynomial function by hand. We're going to follow these 3 simple steps. First, we're going to determine the end behavior. Then we're going to figure out the intercepts, whether it passes through or it turns around. And then we're going to figure out the total number of turning points that this polynomial can have. Okay, so let's do a working example together, and let's do x to the 4th minus 2x squared plus 1. So the first thing that I want to try and do is figure out the end behavior. So because my leading coefficient is a 1, right? Remember there's a 1 thing out front here. And my degree is an even number, that means that I'm going to go up on the left and I'm going to go up on the right. So I know that my end behavior is doing something like that and something like that on the graph, okay? Let's talk about intercept behaviors. If I'm looking for x-intercepts, I want to set this entire thing equal to 0. Because remember, to find any x-intercept, we set y to 0 and we solve. So that's x to the 4th minus 2x squared plus 1. If you can factor, go ahead and factor. So I can pull an x squared out of this thing. That will leave me with an x squared minus 2. There we go. And then a plus 1. And that is not really getting me anywhere for this part. So instead, oh, my bad. If I can't factor, if I can't pull out a factor like that, that's okay. Go ahead and try and factor this thing normally, as into the product of two factors. So what if I did x squared and x squared? Oh yeah, here we go. A 1 and a 1, and then they both need to be negative. That was a little bit tricky because I had to factor this like I normally would, but I have a second degree first term. Okay, so each of these factors becomes x plus 1 times x minus 1 because they're the difference of 2 squares. So x plus 1 times an x minus 1. So this is still set equal to 0. So how could I write this better? This could be written as x plus 1 squared, because there's 2 of them. There's this guy and this guy, times an x minus 1 squared. So this tells me a whole lot of information, right? This tells me that both 1 and negative 1 are zeros, and they have a double multiplicity. So that means at 1 and negative 1, I'm going to have an intercept, and I'm going to have a double multiplicity, which means it's going to turn around, okay? And because this is a 4th degree polynomial, then I can have at most 3 turning points. Okay, so, and I can see clearly from here that 1 is a y-intercept. So therefore the graph must be coming down like this, hitting the 1, turning around, hitting the 1, having another turning point, and then going up on that side. So look, I've got 1, 2, 3 turning points. My end behavior is up on the left and up on the right. I have a y-intercept at 1. I have found my x-intercepts by doing some cool factoring here, which I probably should have brushed up on first before I started this video, but that's all right. And there is the concept of my graph. So that's kind of what we expect you to be able to do, is to graph that polynomial by hand. We want to follow these 3 steps, and you're going to try one right now up on your own. Okay, box number 3 is a U-try, but we're going to do this U-try in stages, okay? So the first thing I want you to do is just tell me the end behavior of the polynomial function f of x equals x to the third minus 3x squared. Okay, hopefully you got that. We have a positive and odd, so it's going to go down on the left and up on the right. Okay, second thing I want you to do is tell me the maximum number of turning points. Maximum number of turning points. Okay, for number 2, hopefully you got the right answer of 2, because we have a degree of 3, therefore there are 2 turning points. Okay, number 3, I want you to tell me the x-intercepts. Okay, hopefully you realize that 0 is equal to x to the third minus 3x squared. Therefore 0 equals x squared times x minus 3 when you factor out an x squared. Therefore x squared is equal to 0, so that's a double root. Or x minus 3 is equal to 0, so therefore x is equal to 3. So 0 has multiplicity 2, 3 has multiplicity of 1. Okay, last step, I'd like you to go ahead and make a sketch of the graph. Okay, hopefully your graph looks something like this. You should notice that at 0 we have a multiplicity of 2, so it's going to turn around. At 3 we have a multiplicity of 1, so it's going to pass right on through. The graph is going down on the left, and it's going up on the right.